Welcome to All This Math. This is Professor Parker, and today we're going to do some factoring by grouping. Now, factoring by grouping. Usually, when we talk about grouping or factoring, we're usually talking about an even number of terms. We usually are dealing with like 4 terms, maybe 6, maybe 8. I've actually never factored by grouping with 8 terms. I factored by grouping with 4 terms, maybe 6. But usually, we're dealing with an even number of terms. That's my point. Here we have a trinomial. We got 1, 2, 3 terms. It's a trinomial, right? And usually, because this is a quadratic trinomial, usually what I like to do is I like to do something I call the swing method. And I've done videos about the swing method before, and I'll do some videos about the swing method again. The swing method is kind of cool, I think. But grouping is also kind of cool, and it employs some of the steps that you have to take with the swing method. And I like those methods. I like factoring by grouping, and I like the swing method because I'm the type, I like algorithms. I like protocol. I like, listen, just give me the set of steps that's going to work every time. I can memorize the process, and then I can just apply it when I see fit. When I recognize the type of problem that this applies to, I can just rock out and just use that method. That's the type person I am. Some teachers like to do the trial and error method of factoring these trinomials, and that's cool too. But sometimes it's easy to do the trial and error method because you'll come up with the numbers that you need real quickly. But then sometimes the trial and error method might take you a minute, especially if you're not that familiar with all the factors of your terms, that being your lead term and your constant. So anyway, factoring by grouping, that's what we're about to do. How do I factor by grouping? Basically, what I need to do is I need to take this trinomial and I need to stretch it out, right? Stretch it out into 4 terms because right now it's got 3 terms, and I need to stretch it out into 4 terms. And the way I'm gonna do that is this negative 16r. I'm gonna break this down into 2 terms, right? And this how it's done. So first you start out with the lead coefficient, which is 3. You multiply it by the constant, which is 20. So you do 3 times 20, and that equals 60. That's step 1. That's always step 1, right? Now, another thing I wanted to say is that we factor by this method because this lead coefficient is not a 1. If this lead coefficient was a 1, we wouldn't have to go through all this. This will be a lot easier to do. We would do something that I tend to call reverse FOIL method, where we just come up with 2 numbers that multiply to make this number, and at the same time, add up to make the middle number. And then those will be my 2 numbers. I will put them in the parentheses in a certain place, and I would take the factors of r squared and put them in the parentheses in a certain place, and I'd be done. Finito. All right? But that's not what we're working with. Our lead coefficient is not a 1. It's a positive 3. So now we do a more involved method. All right, bet. 3 times 20 gives me 60. That's our first step. Our next step is to think of, and this is where having number sense is important. This is where knowing the multiplication table and having it memorized is important. This is where just not even being like a so-called math genius, but just knowing how to manipulate numbers and knowing how to do arithmetic comes into play. Because what you need to think about right now is, what are the 2 factors of 60 that add up to negative 16? Are they 20 and 3? No, because 20 plus 3 don't equal 16. Are they 60 and 1? No, because 60 plus 1 don't equal 16. Are they 15 and 4? No, because 15 plus 4 don't equal 16. But what about 10 and 6? Can my 2 numbers be 10 and 6? I know 10 times 6 equals 60. And does 10 plus 6 equal, wait, that's a negative though. I know 10 plus 6 equals 16. It don't equal negative 16. But check me out though. I can just make this 10 negative and this 6 negative. I can make the 10 negative and I can make the 6 negative. And then that still satisfies my need for the 2 factors, because negative 10 times negative 6 still multiplies together and equals positive 60. So now these are my 2 numbers. I'm going to use these 2 numbers to stretch out this trinomial. So watch what I do. I'm going to switch the color up on you for this part. Right? So the first term stays the same, 3r squared. The middle term changes. I basically take this negative 16r and I break it apart into two parts. One part is going to be negative 10r. The other part is going to be negative 6r. And then this 20 stays the same. So like I told you from the beginning, when I factor by grouping, I want to stretch this trinomial out into a 4-term polynomial. And that's what I did, right? So I ain't lied to you. I told you that's what I was trying to do, and that's what I did, all right? And notice how I really didn't change anything. I just expanded it because negative 10r minus 6r is still equal to negative 16r. So this is kind of like doing the reverse of combining like terms. I basically uncombined like terms. So I broke this negative 16r down into these two terms. And whenever we factor by grouping, that's essentially what's going to happen. All right, the next thing I suggest you do when you factor by grouping is you rewrite the expression in two groups. And each group should be inside parentheses. So I'm going to do this. I'm going to do 3r squared minus 10r. And then what I'm going to do is this. See, because this is a negative, what I like to do, everybody might not do this, but what I like to do is I like to always put a plus sign in between my groups. So then in parentheses, I'm going to have negative 6r plus 20, right? So you see how I got my two groups? That's group 1, that's group 2. I got my two groups. The first two terms make up the first group. The third and fourth term make up the second group. And now what I'm going to do is I'm factoring by grouping. So basically I'm dealing with the GCF, aka greatest common factor. I got to pull the greatest common factor out of this group, and I got to pull the greatest common factor out of this group. So the greatest common factor of 3r squared and negative 10r is just r. And then in the parentheses, I got 3r, and I got minus 10. See how I did that? You pull out the greatest common factor, which in this case is r, because that's the variable that they both share. And you take the variable with the smaller exponent. So the smaller exponent is 1, so that's r to the first. And then I divide this first term by r, giving me 3r. I divide the second term by r, giving me negative 10. All right? I'm going to do the same thing over here. What is the greatest common factor of negative 6 and positive 20? I'm going to make it negative because whenever I have a negative sign, that's another little trick, a little cheat code. Whenever you have a negative, this makes your work easier. Whenever you have a negative inside of these parentheses in this group, you want to pull out the negative value, the negative GCF, not the positive GCF. You want to pull the negative joint out, right? So the greatest common factor of 6 and 20 is 2. 2 goes into 6, 2 goes into 20. And I make it negative because the 6r was negative. So then I divide this. Negative 6r divided by negative 2 gives me positive 3r. Positive 20 divided by negative 2 gives me negative 10. Now, what do we notice? I know you notice it. You notice that you got 3r minus 10 over here, and you also got 3r minus 10 over here. Right? So whenever these match up inside the parentheses, you know that you're on the right track. Now I'm going to switch black to the blue. All right? Now, when that happens, you're going to have two binomials multiplied by each other as our final answer. You take this r, whatever's outside the parentheses, in this case, r and negative 2. You're going to put them together, right? And then whatever repeats, you write it down one time. Because essentially, 3r minus 10 now is the greatest common factor of each of these. So it's like 3r minus 10 actually could be written first, but it doesn't matter what order I write them in. You can write 3r minus 10 first and the r minus 2 second, or you can write r minus 2 first and the 3r minus 10 second, because multiplication is commutative. That C word, meaning the order doesn't matter when you do multiplication. So this is our answer. But again, we should always check our work, right? So I'm going to FOIL this out. I'm going to do r times 3r, which is 3r squared. I'm going to do r times negative 10, which is negative 10r. I'm going to do negative 2 times 3r, which is negative 6r. I'm going to do negative 2 times negative 10, which is positive 20, right? And then I'm going to combine like terms. And I'm going to get 3r squared minus 16r plus 20. And that is what I started with, right? So that's proof that this is the correct answer. And there you go. So whenever you're confronted by A quadratic, biggest exponent is a 2. Trinomial, 1, 2, 3. The lead coefficient is not a 1. Try this method out. You might like it. Remember, all you got to do is multiply the first lead coefficient or the first term by the last term. You get that number. Then you find two magic numbers that are factors of that product and also add up to the middle coefficient. And then you take those two numbers, use those two numbers to break down the middle term into two separate terms. And now you got 4 terms. And then you just use your skills at factoring by grouping. And I think what I'm going to do too, I'm going to do some just straightforward factoring by grouping videos too. Just so we know how to factor by grouping. Because factoring by grouping is important, right? All the different types of factoring are important. All right? So that's it for now. This is factoring by grouping. This has been All This Math. Please continue to send your problems to the All This Math inbox, and your problem might make it to this board. Peace.